Hey everyone. So again, I'm not with you today, just like I wasn't yesterday, but I will be back tomorrow. And so I just got done recording the video that you watched yesterday, and I realized after I was done and I saw how long the video was that that last part when I went through the packet was a bit longer than I had hoped. So thank you for sitting quietly through that and paying attention if you were able to do that. I'm going to try to keep today's videos a little bit shorter and give you more time to work. Um, but at the end of yesterday's video and yesterday's class, I wanted you to have time to work on this, the ratios performance task, the one with the camping map or whatever. And I'm imagining that probably didn't really happen. And so I want this to be your homework. This one right here. If you got it yesterday, the one that says ratios practice performance task, then that's great. Do it, keep it, turn it into me on Thursday or Friday, depending on what period we're watching this. Today you should have homework due, but it should be online homework. So there shouldn't be anything to like turn in to the substitute teacher today. Okay, so yes, this one becomes your homework. Please do this. Today is going to be all about, and I think there should be a stack of extra copies of this somewhere. Get it from the substitute teacher, wherever it's at right now, if you don't have this. All right, moving on. So today's going to be all about solving equations, and we're going to be doing two-step equations. We had another day, a little over a week ago, where we were just solving a bunch of equations, but they were all one steps. Now we're doing two steps, and I would consider solving two-step equations to be the most important thing you learn how to do in seventh grade math by far. So maybe with the exception of writing equations, you could say is just as important as solving, but either way, this is like the important stuff of seventh grade here. And so let's make sure we're doing this right. Throughout this entire class period, when you're writing as you solve, I want it to look neat. I want things to be in line where they should properly. I want every step shown. So since it's two steps, every time I look at one of your equations, it should show a step and then a new equation and then a step and then a new equation. That last new equation will be the solution. Your equal signs should be in line the whole way. Let's make sure we're doing this right the whole time, please. So you should have picked this one up as you walked in the door, I believe, if the substitute teacher set it up over there where I usually have stuff for you to pick up as you walk in. Otherwise, maybe they're passing it out right now or whatever, but you should have this one. It says, make sure to show your work conventionally. That's what I'm talking about. So each of these is two steps. Each one will require either an addition or subtraction first, because remember, when we solve equations, we do it in SAD-MEG order. And so each one of these will require some sort of subtraction or addition as your first step, and then some sort of division or multiplication as your second step, and then you should get your solution. So I'm going to do like two examples real quick. I don't know why examples was a hard word to think of all of a sudden. I'm going to do two examples real quick. Then I want to give you some work time. And then I'm going to show a couple more. I don't know if I'll go through all of them. And then we're going to move on to something else. So a couple of examples. Here we got -3 plus n divided by 4. Remember, this means division, fraction bars, right? So my two operations that I see in this equation is -3 is being added, and then n is being divided by 4. So I want to get rid of this adding a -3. So I'm going to add +3. Usually we use the opposite operation, right? Like if it says +3, we do -3. If it says -3, we do +3. Well, I want you to think of adding -3 as the same thing as -3. So the opposite of that is +3. In the end, our goal is to make a 0. -3 and +3 make a 0. And that's what we want. We want a 0. So the equation becomes n divided by 4 plus 0. But we just don't write the 0. So I'm going to add 3 over here. I got to do one to the other side of the equation too. I'm going to zoom way in. So I'm going to add 3 over here. And so -3 and +3, they make a 0. So they go away. You don't have to cross things out like this. I do it when I'm teaching. And I get n divided by 4 equals -1 plus 3 is +2. Now, n divided by 4 the opposite operation of that is to multiply by 4. So let's multiply both sides of our equation by 4. We could do it by showing 4s with parentheses on the sides or going underneath and writing dot 4. We don't write little x4 though. We don't use x's to mean multiplication when we're solving equations. I'm going to go parentheses on the side because I don't think I showed every period this, the one day we were doing these equations. I think there was like 1 or 2 periods where I forgot to show that you could show your multiplication work by writing the number that you're multiplying by on both sides in parentheses on the sides. So what we get here is 4n divided by 4. The 4s cancel out and make a 1. So we have 1n equals 2 times 4 is 8. And divided by 8. And you could mentally go back and verify real quick. If I put an 8 for n, let's see here. 8 divided by 4 is 2. If I add that to -3, I would indeed get -1. So verified. I didn't write it, but I did it in my head. All right, now this one, we've got a is being multiplied by 5. So we're going to have to divide by 5 when we get to that. And it's subtraction by 1. So we should add 1 to get rid of that. So I'm going to go +1 here. I got to add 1 to the other side of the equation too, making sure my work is nice in line. So I got 1 + 1 on either side of the equal sign. They're not both on the same side. And so now we're left with 5a equals, let's see here, -16 + 1 is -15. And so this says 5 times a equals -15. Let's divide both sides by 5. Remember, when you're showing division as your solution step, you can use division signs or fraction bars. Those are both okay. And so 5a divided by 5 leaves you with just 1a, and -15 divided by 5 is -3. Okay, so you've got 8 more to do on this page. Once you kind of get going on them, they don't take much more than a minute to do. So I'm going to ask the substitute teacher to give you about 8 minutes to work on these, whether I'll let it be the substitute teacher's decision, whether you can just stay at your groups or if you can move around the room. And then if they could just pause this video and restart it in about 8 minutes, and I'll go over a few more of them. Okay, so hopefully you've had about 8 minutes to work on these. Let's do a few more. I'm going to go a little bit slow at first, right? Still explaining, but then I'll just do a couple a little bit faster for you to watch. So this says 5 plus a divided by 3. So I've got addition by 5. So let's get rid of that first by subtracting 5 from both sides of the equation. So +5 and -5, or +5 and -5, whatever you want to think of it as, they cancel out and make a 0. Go away and leave us with just a divided by 3 equals 7 minus 5 equals 2. This process that we're doing, where we're purposely doing the opposite of each thing, so things like go away, right? The 5 goes away because we subtracted 5. This 3 is about to go away because we're going to times by 3. We're like breaking the equation down step by step to get the variable all by itself, and that's called isolating the variable. That's a pretty important like vocab phrase. So know that what we're doing is called isolating the variable. Okay, this time I'll write .3 underneath to multiply both sides of this equation by 3, just to do it differently than I did before, even though really based on the amount of space I had, it was probably actually a better choice to go parentheses on the side, whatever. And so a divided by 3, but then times 3, leaves us with just a, and 2 times 3 is 6. So a equals 6 on that one. Remember to always, when you're solving equations, if you have a subtraction or addition in the equation, you should deal with that first. And then if you have a division or multiplication, that should get handled second, right? SADMEG order. So in this case, -4 is being added, and then v is being divided by 2. So let's get rid of adding -4 by adding +4. Those things will make a 0 and go away. So we got to add 4 to the other side of the equation, and we get v divided by 2 equals -6 plus 4 is 2. Do you think maybe you could, thank you, sir. And so in yesterday's video, we had the parked car announcement, and in today's video, custodians trying to come in and clean the classroom while I'm in here doing this. Okay, so we've got v divided by 2 equals, oh, I almost dropped a negative sign there because I got distracted. So -6 plus 4 is -2. And then now I'm going to multiply both sides by 2 again. This time I'll write my multiply by 2 as parentheses on the side. You might be able to hear that noise in the background as well. They're doing some kind of work in the hallway today, some construction or something. And so what we wind up with here is 2v divided by 2. That leaves us with just 1v. And then -2 times 2 is -4. All right. I don't know if I want to take the time to do every single one of these, just because I want you to try something else. So let me just scan the paper real quick to see if there's like one more really good one that I want to do. I think I'm going to do 6 and 8. And then hopefully you got a chance to check your solutions with the people around you. And if you all got the same solution, you probably did okay. So I'm going to add 1 to both sides of this equation to get rid of this -1 that's being added on the variable side of the equation. So I'm going to add 1, but then I add 1 over here. Look, that's going to create a 0 over here, right? But that's okay. You're allowed to like have zeros as part of your solving process. So we get n divided by 1 equals 0. But we don't even really have to do anything here, right? Because n divided by 1, doesn't that just mean n? Like some number divided by 1? It's still just going to be n. Like I suppose I could multiply both sides of the equation by 1, but that wouldn't do anything. So really this just says n equals 0. So I guess you could argue that this was really a one-step equation, not a two-step equation. I'm just going to write n equals 0 here. And that's totally okay. You're allowed to have your variable represent 0. There's nothing wrong with that. Okay, and then lastly, I'm going to do this one just because it has multiplication in it by a negative number. And it seems like a lot of the other ones I've done have had division in it. And I just want to make sure you're seeing me do both. So -5x plus 3. I'm going to subtract 3 to cancel out this plus 3. Geez, now somebody's revving a motorcycle outside. A lot of noise today while I'm trying to do this. And so I'm going to subtract 3 from both sides of the equation. This plus 3 and this minus 3 create a 0. That's what we say when we say they cancel each other out. And so we're left with -5 times x equals 5. Now, this part can be a little tricky for some people. The number that's multiplying by our x, we call it a coefficient, is -5. That's the number we want to divide by, not just regular 5. Because if you do, you're going to get the opposite of the answer you really want, solution, I should say, instead of answer. So let's divide both sides by -5, because that -5 divided by this -5 is going to create a +1, leaving us with 1 regular positive x, which is what we want. So we got to divide this side by -5 as well. We're left with 1x, not -1x, that's important here, equals 5 divided by -5 is -1. If you did it the other way, you would have got -x equals +1, which says the same thing, but just in a weirder way. So this is the way we prefer to have it. All right, hopefully you got an opportunity to check your solutions with on the other ones with people. If you didn't, maybe there's time to do that later in the period, but I want to move on to this other thing that you're doing today. So this other one that like maybe whoever's substitute teaching today could, after I maybe show an example of this, they could pass this out, or you can pause it right now real quick and pass it out and then press play, whichever one works for you. But either way, you're going to get this one. This is more two-step equations, but this time we've got the equations written in factored form. And I want you to see the difference in the two strategies you could use to solve equations when they're in factored form. So this says 4 times 3x minus 5 equals 64. Now, if you think about SADMAG order, SADMAG, right, which I have written right up here, the G stands for grouping. Anything that's grouped, you could choose to do last when you're solving, right? Usually when you do math, that's supposed to be the first thing you do. You got to do the thing in the parentheses first, right? Well, when you solve, you can save it for last because we're doing things in reverse. And so this 4 that's being multiplied by all this stuff, multiply actually comes before grouping now. We could get rid of that first if we want to. The way you would do this is by dividing the entire side of the equation by 4. I'm not just dividing 4 by 4. I'm dividing everything by 4. But I don't put my division symbol underneath the equal sign. I almost did there on accident. And I divide this by 4. Now, this is where it gets a little confusing for some students because I just said I'm not just dividing the 4 by 4. I'm dividing everything by 4, but it's going to look like I'm only dividing the 4 by 4. Because what this says is 4 times a bunch of stuff. But if you times anything by 4 and then you divide it by 4, you're left with just one of that thing. Another way of thinking about it is this says I have 4 groups of 3x minus 5. When I take those 4 groups and I divide them among 4 people, each person's going to get one group of that thing. So if I have 4 quantity 3x minus 5s and I split them among 4 people, each person's going to get one quantity 3x minus 5. And so what really happens is this 4 and this 4 create a 1 and they cancel out. And so I know that's tough to think about because I just said you're not just dividing the 4, you're dividing everything, but then it kind of looks like I'm just dividing the 4, right? You got to really think about it. And so what I'm left with is 3x minus 5. So because this 4 and this 4 created a 1, I don't actually do like this doesn't become 3 divided by 4x or like 3/4 x. No, this doesn't become 5 divided by 4. The fact that they're grouped and there's 4 of them is counteracted by dividing by 4. So I'm left with 3x minus 5 equals 64 divided by 4 is 16. Now we just have a good old regular two-step equation, like you just practiced a million of, right? Like we're going to add 5 to both sides, and you get 3x. I should have written smaller. I'm going to run out of space here. 3x equals 21. Okay, so for the sake of space, I'm not going to write my step. My step should be to divide both sides by 3, but I don't really have the space to do it. But if I divide both sides by 3, I would get x equals 7. You need to show all your steps, so write smaller and better than I did, please. Now look, over here, this is the exact same equation as this. If you took this 4 and you distributed it, 4 times 3x is 12x. Boom. And 4 times a minus 5 gets you a minus 20. And so this is the other strategy you could do. If you get an equation that looks like this, 4 times 3x minus 5 in parentheses, you could solve it this way. Divide by 4 first and then do the other steps like I did. Or you could distribute the 4, get 12x minus 20, and then solve. Some people would actually really consider these 3-step equations, right? Because I had to divide by 4 on both sides here, then I had to add 5 to both sides, and then I had to divide by 3 here. On this one, I got to distribute. That's a step, kind of, right? And then it looks like I'm going to add 20 to both sides, and I'm going to divide both sides by 12. So I would argue you could call these 3-step equations. On this one, I'm going to add 20 to both sides, and I get 12x equals 84. Now I divide both sides by 12. And I get x equals 7. 84 divided by 12 is 7. Because these are the exact same equation, just one of them is in factored form and one is distributed into standard form, you should get the same solution on both sides. They're the same equation. They should have the same solutions. You're just practicing the 2 different ways to solve it. Here, you could divide by -3 first, and then solve the bit that's inside the parentheses. Or if you distribute the -3, you would get 6x plus 12, and then you could solve from here. I want you to practice both ways so you can get used to both ways. So let's see here. This video is about 20 minutes long at this point, and I know you got 8 or 10 minutes to work. So that means we should be about 30 minutes into the period at this point. So I'm thinking you should get another 8, maybe 10 minutes or so to work on this page. And then give me the last 6 minutes of class or whatever that is to do a couple more examples. So if whoever is teaching the class could pause it here. And then when there's about 6 or 7 minutes left in the class, have everyone settled, quieted down again to watch the last bit of this video. Okay, so assuming everything's going the way I planned, there should be about 6 minutes left in the class. Let's just do a couple more of these. So here, when you solve the factored form version of this, you divide this entire side by -3. So this fraction bar says divide the whole thing by -3. And I got to divide this 42 by -3 as well. This -3 on top and this -3 on bottom create a 1. And so you could say they cancel out. And what you're left with is, I'm going to write it over here a little bit. I'm going to break my rule about keeping my equal signs in line just to kind of create more space for myself. This is going to say -2x minus 4. So I'm just taking the stuff from inside the parentheses equals 40. Oops, no, I need to divide by -3 over here. So 42 divided by -3 is -14. I have a -4 in my equation, so I will add 4. And I get -2x equals -14 plus 4 is -10. And so I divide by -2 on both sides. And I'm running out of space again. Oof. I wish I'd have made these boxes a little bit bigger now that I'm working on this myself. I hope you didn't find that too annoying while you're doing this. It looks like I'm just going to draw an arrow. X equals -10 divided by -2 is 5. And so I should get x equals 5 over here as well. That's the idea, because this here, 6x plus 12, is the same as if you distributed the -3 through these parentheses. And so these ones seem a little bit easier to solve, but you got to remember that you can only get to this if you distribute this one first. So there's that extra step there. I subtract 12 from both sides, and I get 6x equals 30. And then I divide both sides by 6, and I get x equals 5. Okay, on this one, you could divide both sides by 1/2, but dividing by 1/2 is exactly the same as multiplying by 2. I even tried to give you this little hint here, because what you're really trying to do is turn this into a 1 to make it go away, right? So on this one, we could go parentheses 2 on both sides. That turns this 1/2 into a 1. So we have one group of 10x plus 8. And then 19 times 2 is 38. And now we just solve regular. I'm going to subtract 8 from both sides, and we get 10x equals 30. Divide both sides by 10, and we get x equals 3. I'm pretty confident that you were probably able to solve this one. I think the last thing I'm going to do, because I'm trying to judge and look at the time, and I'm thinking there's 2 or 3 minutes left in class. Hopefully you're still paying attention and not packing up, trying to rush out or whatever. This one, I left the distribution for you to do. Like, you had to actually write the new equation over here. So hopefully you went 4 times -2x is -8x. And 4 times 1/2 is 2. So you get 8x plus 2. Still going to equal -22. You don't distribute this 4 to the -22 way over here on the other side of the equal sign. I hope you didn't do that. And then we could just solve. I'm going to divide both sides by 4. So these 4s cancel out, as we say, and we get -2x plus 1/2 equals 22 over 4. -22 over 4, I should say. All right, so I'm just leaving it as a fraction. So this one's not even going to come out. It kind of doesn't look like this one's going to come out to a nice whole number. So I'm going to subtract 1/2 from both sides. And I know 1/2 is the same as 2/4. So this is -2x equals -24/4. I thought of this as -2/4 or -2/4. So I got 24/4 total. And then you divide by 2. -2, I should say. Divide by -2 on both sides. And you get x equals, I should have half as many fourths, right? I have -24/4. So now I should have -12/4, which is -3. I hope I did that right. I'm trying to rush because I know class is about to end. Oh, and on this one, I don't remember what the answer is, but I tried to give you a hint that I don't think this one comes out to a nice whole number. It comes out to like 5, no, 2 point, is it 2.5? Yeah, 2.5. You got 2.5 on that one. You got it right. Okay. I'll see you guys tomorrow.